Hello, we will now look at how to write the stress components in the cylindrical coordinate system. For this, we first look at what is a cylindrical coordinate system. A cylindrical coordinate system is written in terms of the radius vector, the angle, and the height z. Okay, now we shall write a section of a cylinder and this comes the part of the cylinder section which is along the z, and this is our axis. And it goes all the way till here, and we draw a similar parallel line here. No, this is not parallel. It should come till about here, I guess, huh? This there. Slightly got this place. Now we shall draw this down till this line. And this curve joins here. This joins here. We have a cylinder, part of a cylinder. Now I shall highlight those lines which are not hidden. This is a top face. Okay. Now the thin lines are the hidden lines. Okay. Now our R goes like this: radius vector and theta. For this purpose, let us take that theta is positive clockwise and z is positive up and r is radially outward. For a curved face like this is positive. Now we'll start by identifying the center points of each of the faces. Center point of this face, center point of the back face, center point of the top and the bottom, and this one and the opposite one. Okay, now normal stresses act perpendicular to a face, so we shall write one vector which points normally outward, normal to this face in the outward direction. One is this, and here is this one, and for this is the top one, and the bottom one, and for this is this one, for this is this one. Okay, now radially outward normal force is sigma r, and here sigma r and sigma z sigma z, this is sigma theta, and we have another sigma theta. Okay, now we shall try to understand how to write the shear stresses. Shear stress used by tau, denoted by tau, sorry. Now at this point, let us consider this point. The positive normal stress is in this direction. That is one positive direction for this point. The other two positive directions are one along the positive z, positive theta, or clockwise, positive theta. Another is along positive z. Okay. Now for this, the other two positive directions are, one is radially outward, like this, okay, and one is along the z direction. And for this, radially outward, going like this, and one along the positive theta. And if we consider the other faces, this is going in the negative direction, so the other two negative directions for this is, one is along the negative theta and one is along the negative r. And one for this is the negative theta. The other two directions which are negative are one along the negative r and along the negative z. And for this, one along the negative theta and the other along the negative z. Now this is the direction of the shear force, shear stress, so tau, and this is how to write the indices. Now the normal stress at this point is radially outward, so R, okay, and this is acting along Z, so tau RZ, and tau R, and this is along the positive theta, so theta. Okay, so now we will write for the opposite phase, which is this. Sigma R is positive here, and so this should be tau R. Normal force at this point, normal stress at this point is along the radial direction, so we will write down R, and this is along the negative Z or Z, tau RZ, and this is tau R negative theta or theta, tau R theta. Okay, now you just consider, just see here, this is tau R theta and tau R theta, equal and opposite. Okay, now tau RZ and tau RZ equal and opposite on the opposite faces. Now we'll write here, what is here, theta is the normal stress, sigma theta, so this should be tau theta and Z, and this must be tau theta and positive R, 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 R. Okay, now opposite face is this, so this should be tau theta and radially inward R, this should be tau theta Z, tau theta Z. Okay, here also you can see tau theta Z is positive, tau theta Z is negative, equivalent or opposite. Okay, now we'll write for the top face and the bottom face. Top face, this should be tau Z R, and this should be tau Z and theta, and this must be tau Z and theta. This is tau theta, sorry, tau, z, and r. Okay, so now we have written the equilibrium, or now we have written the stress components under equilibrium for a cylindrical element of body. Let us consider, for curiosity, this section. We'll consider this section, which is like this. The points here are, this line is supposed to pass through this point. It's not exactly written like that way. If you write in the right manner, then this point will coincide here. These points here. Okay, now this is sigma r, and sigma theta and sigma theta. Okay, and we have a tangential component at this place, which is like this, and a tangential component here like this. Okay, now this is tau r theta, and this is tau theta z. This should be tau. This is the axis z r, and theta, and this is tau theta r. Okay, now if we consider this figure, the moments, or the force which is causing this shear stress produces a moment about this point, and so does here. They tend to rotate it here like this, and this consequently these two tend to rotate in the anti-clockwise direction, so they both should cancel out each other. Okay, and the deformed state will look like this. If you consider this as the curvilinear diagonal, and this extends here and this extends here. Okay, now, and this comes back. If you write the deformed state, it should look like this. This is the deformed state, and this analysis can be made for any other section. If you take a section in this manner or in the other manner. Okay, thank you.